A second way in which we perform raster overlay analysis in GIS is map algebra, which are mathematical operations performed on georeferenced numbered arrays. And it sounds really fancy, but arrays are just rows and columns of cells in a raster data set. And number are the values assigned to each of those cells in the raster data set. And georeferenced, of course, means that the raster data set is georeferenced. And where you have raster data sets that are georeferenced to the same location and the cells are coincident, you can perform mathematical operations on those. So in this conceptual example that you see on your screen, I've got preferred vegetation, prey habitat, and landform for the Canada lynx. And my input for my map algebra are the preferred raster data sets that include vegetation, prey habitat, and landform. And then the action is I am adding the coincident cells in each of these raster data sets together. And then, of course, my output is the preferred habitat for the Canada lynx. And so the higher scoring the values in the preferred vegetation, prey habitat, and landform, the higher the score in the cells for my suitability index for the Canada lynx. And if you look to the right, you can see the actual map algebra expression that we utilize to create our suitability index for the Canada lynx habitat. The expression is vegetation plus prey habitat plus landform equals the output raster, in this case, the lynx habitat. In ArcGIS, we use the raster calculator to build and execute a map algebra expression. And if you look at the left-hand side of your screen, you can see the raster calculator interface accessed from the geoprocessing tools. It includes the rasters, which are the input rasters that you're going to utilize in your expression, the tools, which actually include the operators, functions, and tools that you're going to use to act on your input rasters. And then below those two areas, you can see the actual text box where you're building the map algebra expression. In this case, it's raster is my input raster, times, which is my math operator, and 2, which is a constant. And what this expression is going to do is going to multiply every cell in the input raster times 2 and save that to my output raster. In this case, it's raster x2. And if you look at the example on the right, you can see I have my input raster with all of my cell values and then my output raster. And every cell in my input raster is multiplied by 2 and saved to my output raster. So the cell that is in the upper left-hand corner is 9 in the input raster and is 18 in the output raster. Or all the cells that are 10 in the input raster are saved out as 20 in the output raster because 10 times 2 is 20. Now, I mentioned previously that tools include operators, functions, and tools. And operators are mathematical symbols applied to the input rasters. That's just plus, minus, times, divide, for example. And in the raster calculator on the left, you can see that my expression is raster times raster. So times is the mathematical symbol operator that I'm utilizing to multiply my in raster times an output raster in this case, rather than a value. So it's going to be raster times raster, and the output is going to be saved in my output raster, which is raster x raster. And if you look at the example on the right, you can see there's my input raster. And if I multiply every cell in my input raster times every cell in my input raster, I get my output raster, which is raster x raster. The cell in the upper left-hand corner is 9, and 9 times 9 is 81. Or all the cells that have the value 10, 10 times 10 is 100. In addition to operators, another action that we can apply to our input rasters are functions, which are mathematical transformations applied to the input rasters. And in the raster calculator example on the left there, you can see some examples of functions, round up, square, square root. And in this particular example, we're utilizing the square root function on the in raster, which is raster x raster. And so what this means is we're going to calculate the square root for every cell in raster x raster. And then that is going to be saved to the output, which in this case is raster sqrt, or square root. If you look at the image on the right, you can see that we've applied the square root to every cell in the raster x raster. And that's reflected in the resulting raster sqrt. So the cell in the upper left-hand corner is 81 in raster X raster, and the square root is 9 in the output raster. Same goes for all the cells that are 100 in raster X raster. The square root of 100 is 10, and that's reflected in the output raster square root. A condition is a typological operator that you can apply to the input rasters. And if you look at the raster calculator image on the left, you can see in the tools sections there are conditionals, including the CON, which we've used in the expression below, along with a where clause. So if you look at the syntax, you can see that it's CON or condition, and you have your in raster, and then your where clause. And if it evaluates to true, then you assign the true raster value or constant. And if it evaluates to false, you assign the false raster or constant. And in this example right here, we've got CON for our condition. Raster is our input raster. Our where clause is value is greater than 10, which means that all cells where the value is greater than 10, we're going to assign the constant 1. And all cells where the value is not greater than 10, where it's false, we're going to assign the constant 0. And so if you look at the image on the right, you can see I've got my input raster and then my output raster conditional. And every cell where the value is greater than 10 is assigned a 1, and every value where it is not greater than 10 is assigned a 0 in the output raster conditional. Conditionals can be thought of as very simple if, then, else statements. If this, then this, else this. The last type of action in the raster calculator that you can apply to in rasters are tools. And tools are just that. They're geoprocessing tools that you can apply to the input rasters. So most of the geoprocessing tools that are available to you in the ArcGIS toolbox can also be accessed via the raster calculator. In this case, I'm utilizing the focal statistics geoprocessing tool. And you can see the general syntax for geoprocessing tools in the raster calculator as represented in that callout box, in which you've got the geoprocessing tool, the in raster, and then any required or optional parameters that you need to run the geoprocessing tool. In this particular example, we're running focal statistics with raster as our input, and then I've set the parameters for the neighborhood rectangle to be a 3x3 cell, and I've set the focal statistic to calculate at minimum. The results will be saved in our output raster. In this case is raster focal. Looking at the image on the right, you can see I've got my input raster, and then I've calculated the 3x3 neighborhood raster focal statistics for every cell in the output. And it's not just mathematical or statistical tools that you can utilize in the raster calculator. You can use slope, you can utilize the buffer tool, you can utilize most of the geoprocessing tools accessible in the ArcGIS toolbox. Now, I've mentioned syntax a couple of times, and syntax is just the order of the map algebra expression required by ArcGIS. And if you don't have the syntax right, it won't run correctly. And so in the raster calculator example on the previous slide and in the image on the left, I'm using the focal statistics geoprocessing tool, and the syntax required to run that geoprocessing tool as map algebra in the raster calculator. Now, how did I know what the syntax was? I just looked it up in ArcGIS Pro Help. So I went to ArcGIS Pro Help online, typed in focal statistics, and brought up the tool. There you can see a summary of the tool along with the illustration and an example of what the focal statistics command looks like to get the results as seen in that illustration. And if you scroll all the way to the bottom, you'll find a section called parameters, which actually has the syntax for the actual command. Any parameters with parentheses or hard brackets are required, and any parameters with curly brackets are optional. And then you can see each parameter listed in the table along with the explanation and the data type. And so you don't have to be a programmer to utilize geoprocessing syntax in the raster calculator tool. You just need to be able to look it up online and then experiment in the raster calculator tool till you get the results that you're seeking.